Welcome to Calculus. Today we will investigate finding antiderivatives and indefinite integrals. We'll take a look at 4 examples. Our first example is the integration of 3x cubed minus 6x squared plus 2 dx. We'll start off with this example by treating each of these terms individually in the integration. So as I write my next step to integrate this polynomial function, I really need to think about how I would find an antiderivative for each of these terms. So I'll start with 3x cubed. I'm going to keep the constant 3, but then as I would think about x cubed, if that was my derivative and I was looking for an antiderivative, in other words, backing up to an original function, that would be 1 over 4 x to the power of 4. So I'll include that with both parts there. Once I've finished with that first term, I'll now turn my attention to the next term. So negative 6x squared. So again, I'll put plus, include the negative 6. And then similarly, if I'm thinking that x squared was my derivative and I was looking for an antiderivative, that's going to be 1/3 x cubed. We'll include both of those factors, so 1/3 and x cubed. And then our last term here is just plus 2. So the way I would integrate that is just plus 2 times simply x. What I do need to include here, since this is an indefinite integral, is an undefined constant term, which I'll just call c. I have to include that because I don't have limits of integration to evaluate an indefinite or a definite integral. And if I'm thinking in terms of antidifferentiation, if I was to differentiate this, that c in differentiation would become 0. So I have to include it in the integral as kind of an unknown, but it's standing for a constant term. We'll clean this up by simplifying. So this is going to be 3/4 x to the power of 4. Negative 6 times 1/3 is minus 2 x cubed plus 2x plus c. And I'll go ahead and box that as our answer for the integral. We do want to check the result by differentiation. So if I was going to differentiate this, what I should see is exactly my original integrand, 3x cubed minus 6x squared plus 2. So let's just do our check. And again, we're differentiating here. So this is going to be 3/4 times the whole power of 4 is a coefficient. So that's going to become just 3. And then x to the power of 4 minus 1 is 3. So that's going to become 3x cubed. To differentiate negative 2x cubed, that's going to be negative 2 times the whole power of 3 as a coefficient, x to the power of 3 minus 1 or 2. So that's minus 6x squared. And then differentiating 2x, that's just plain 2. And differentiating plus c, that's standing for a constant, so that would be plus 0. So you can kind of see from this perspective why I need to include that plus c. It disappears in the integrand when I'm differentiating. And so in a way, I've lost information. I don't really know what that specific c value is. And so I just leave it as an unknown, a variable. Our second example involves a root, the 4th root. We want to integrate here the 4th root of x cubed plus 1 dx. For this type of setup, I want to rewrite the root as a rational power. So I'm going to re-represent this integral as the integration of x to the power of, so remember the power is going to be in the numerator, so 3, and then the radical or the root will go in the denominator. So it's going to be x to the power of 3/4. That's the same as the 4th root of x cubed. And then I'll just write plus 1 dx. So that's ready to integrate now. So I am looking for an antiderivative to x to the power of 3/4. So if I were to think that that's my derivative, and we're going to back up to an antiderivative, that's going to be one more than 3/4 for my power. So it's going to be x to the power of 7/4. And then I need to include a coefficient that's the reciprocal of that. So I'll write 4/7. So as I integrate this example, the way that my antiderivative is going to look like is exactly as I've written there, 4/7 x to the power of 7/4 plus integrating 1 is just x plus c. And that integrates pretty directly there. Just like with our first example, we want to check by differentiating to see if I can get back to my original integrand. So I'm going to highlight the original. We'll see it in this format where the root is written as a rational exponent. So let's differentiate here. This is going to be 4/7 times the old power as a coefficient, so 7/4. And you can see why we needed that 4/7. It cancels out. Times x to the power of 7/4 minus 1. So I would subtract 4/4. That's going to be 3/4. And then differentiating x is 1. Differentiating c is 0. And so I should see x to the power of 3/4 plus 1. And that's exactly what I had in my original integrand. So differentiation helps us to check that our integration was correct. Our third example looks initially like a rational function. One thing that I noticed with this example, so it's the integration of x to the 4th minus 3x squared plus 5 over x to the 4th dx. My denominator here is just a monomial, x to the 4th. So what I can do is distribute it to each term in my numerator and rewrite this as the integral of x to the 4th over x to the 4th plus negative 3x squared over x to the 4th plus 5 over x to the 4th. And then what I'll do is I'll simplify each of those fractions. So this is going to be equivalent to the integration of 1 minus 3. In fact, what I'm going to do is I want to write it as a negative power, minus 3x to the power of negative 2 plus 5x to the power of negative 4. And the advantage of writing it in that format is it now is basically a polynomial. So as I go to integrate, the 1 is going to become an x. The derivative of minus 3x to the power of negative 2, I'm going to put that, I'll put a plus and then the factor negative 3. Let's just investigate. So if I had the derivative x to the power of negative 2, the antiderivative would be x to the power of negative 1, but I would need to include a negative out front to cancel it. So I'm going to put negative 1 x to the power of negative 1. Then we'll do something similar with this last term. I'll write plus 5. And then I'm just going to think about x to the power of negative 4 as a derivative. Searching for its antiderivative is going to be x to the power of negative 3. But then I have to include the reciprocal negative 1/3. And that concludes the initial integration. I do need to include my constant of integration there, plus c. And we can clean this up now. So I am going to convert these back to rational expressions with a positive power on x. So it's going to be just x minus, plus, those minus signs are going to cancel, 3 over x to the power of positive 1. That's going to become positive power when it descends to the denominator, minus 5 over 3x cubed plus c. And that completes the integration. Again, we should check it to make sure that the derivative matches my initial integrand. So again, let me differentiate. So I'll highlight the integrand there. That's what it's going to look like, hopefully, when we differentiate. So we'll just take what we just wrote here and differentiate to check. So to differentiate x, it's going to be 1. Differentiating 3 over x to the power of 1 is going to become plus 3 times the old power negative 1 as a coefficient times x. If that's the power of negative 1, it's going to become x to the power of negative 2. And then plus negative 5/3 I'll give as just a single coefficient factor. And then to differentiate 1 over x cubed, that's going to be negative 3. Let me make sure. Yeah. Okay, good. Yeah. So that's going to be negative 3 as my old power and become x to the power of negative 4. And then the derivative of the c is just 0 again. So again, we can see that that was lost in the integration. So simplifying down, this is going to become 1 minus 3 over x squared. My 3's are going to cancel, as will my negatives, so that's plus 5 over x to the power of 4. And I can see that that essentially matches my integrand that I've got here. 1 is equivalent to x to the 4th over x to the 4th. We're seeing a similar simplification cancellation in x squared over x to the 4th. But that functions as a check for us. That matches up. Our last example is the integration of cosine of x plus 3 to the power of x dx. So here what I want to do is treat this again as 2 different integrations. I'll do it term by term. And where we'll start here is with integration of cosine of x. So just to think about that as an antiderivative, if my derivative was cosine, the function whose derivative is cosine is sine. So that matches pretty well. Immediately I can begin just integrating. This can become sine of x. And then I need to integrate 3 to the power of x. So I need to recall how that would work. I just need to remember here that if I have, generally speaking, a to the power of x, and I take its derivative, that's going to be the natural log of the base a times the original a to the power of x. So the idea here is if what I have is 3 to the power of x, again, thinking in terms of a derivative, if I'm searching for the antiderivative to that, basically it's going to be 1 over the natural log of 3 to cancel what I would have gotten here times 3 to the power of x. Again, you can kind of check where we're starting here is essentially a to the power of x. If I take its derivative, I need that 1 over natural log of 3 to cancel out because I don't have any type of coefficient in front of the exponential base there. So as we differentiate, or I'm sorry, integrate, we're going to find that this is 1 over natural log of 3 times 3 to the power of x plus c. And that essentially is complete. I'll go ahead and box that. again, what we can do is check by differentiating this expression we just wrote to see if it matches back up with our integrand cosine of x plus 3 to the power of x. So we'll just run our check here. So the derivative of sine of x is cosine of x plus 1 over the natural log of 3. And then remember to take the derivative of 3 to the power of x. It's going to be natural log of 3 times 3 to the power of x. And then derivative of c is 0. So here you can see why we need this 1 over natural log of 3. It's there to cancel with the natural log of 3 that we get if we differentiate. So ultimately what we've got here is cosine of x plus 3 to the power of x. And that matches exactly with our original integrand. Well, thank you for joining for this investigation of these 4 examples of differentiating, of integrating indefinite integrals. See you soon.